welcome everybody to another Queensland AI meetup. Unfortunately, this one we're running online after the lockdown up here in Brisbane, which is a bit of a shame, but I think there's a few different people around the country now experiencing this. So good to have you all here joining us. This week, we're actually joined by Aman from Weights and Biases. Aman is also in lockdown down in Sydney. Unfortunately, he's a little bit more used to it than we are. But actually found some of Aman's blog posts online through his blogging on the Weights and Biases blog a little while ago. And then after we started the Queensland AI and Queensland AI Hub Community Fast AI course, Aman was actually in the Discord and joining us for some of those sessions. And yeah, we sort of connected the dots and decided to reach out and have Aman share some of those recent blog posts and some of his insights with us. So tonight we are joined by Aman. He is working at Weights and Biases now, but part of his talk will be telling us about his journey of how he got there and, you know, how he led some of his own self-education and sharing his work, which is quite cool. So given that we are virtual, what we'll do is Aman's going to go through his talk. Feel free to ask questions, ideally in the Q&A section in the chat. I will be keeping a list of questions, but Aman may also answer those along the way. So yeah, please ask any questions or notes along the way and we'll try and get through as many as we can. Yeah, otherwise, over to you, Aman. Thanks for joining us.
Thanks, Michael. Thanks for having me today. It's a big pleasure for me to be here. While I would have loved to be in Queensland for the meetup, sadly, we're all in lockdown. And I was just saying to Michael, I was reading on Twitter and somebody said, Sydney sneezes and Australia catches COVID. So I'm started here and now everybody's in lockdown. Unfortunate times, but it is the way it is. So then today, the talk's going to be mostly about what's new in CV, which is computer vision, and how to publicly share your work. I've sort of retitled the talk. I've said what's new in CV and architectures. We do plan to share this talk online on YouTube as well. So I'm keeping the wider audience in my mind as while presenting this. So, but feel free to ask me any questions at any time, and I'll make it my best effort to answer all of them. Can you guys see my screen okay? I just want to quickly double check. Okay, excellent. Thanks. So then, as part of this talk, it's not mostly going to be me telling you 5 steps, or these are the 5 steps that this is how you should publicly share your work, or this is what happened in computer vision, and then this is how you should share about it. It's mostly going to be a journey. It's mostly going to be a journey from, as I was on this journey, it was mostly checkpoints. So as I was learning things, I was writing about them. It didn't happen to be that, oh, one day I learned everything that I know today, and then one day I decided I should write all about it. It was mostly an upward curve. And as I was learning, I was also sharing everything I was learning along the way, which has been very rewarding. So I'll be sharing my journey, but through that, I'll also be sharing on what's new in computer vision and how I'll share my experiences on what's worked for me about publicly sharing your work, but then I'll also be sharing some advice on how you can get started with blogging and why that could be helpful. So we'll start with what's new in computer vision. I have this timeline sort of that I created using matplotlib. So let me, it would be easier for me to do it using OneNote. So then we'll be spending the next 15-20 minutes just on these, just on the what's new in computer vision. And this will mostly be a journey of where we started in computer vision and where we are today. Hopefully through this, you'll get ideas about what the latest architectures are or what's new in computer vision architectures, and then how you could take those things and how you could apply them at your own work when it comes to deep learning. So this part of the talk is going to be fairly technical, but then after this, we'll go to the after this, we'll go into the publicly sharing your work section, which is going to be less technical. So as part of my journey, as I said, this is mostly a journey, and I started somewhere here. This is where I started. So let me, sorry, 1 second. So this is somewhere where I started my journey. I wasn't into deep learning until before this time, but this is when I got into deep learning. And the first thing I did, even before I was reading papers, the first thing I ever did was do the Fast AI course. So what's Fast AI? I think Queensland AI Hub has hosted Jeremy Howard previously, and Jeremy has this wonderful course called Fast AI, which is excellent for people who have coding experience and who want to learn deep learning from scratch. So this is an excellent course if you want to get started with Fast AI. If you want to get started with deep learning, then this is a library that will teach you how to do deep learning, and that will teach you how to train state-of-the-art models, best of the best, just using minimal lines of code. So this is where I started. This is, again, it's around this time. So I was doing I did the 2018 course. I did the 2019 course. I did the 2020 course. And since then, I've just been a part of Fast AI community. So let's see. So when I was here, after I did the Fast AI course, the Fast AI course sort of touched upon a few. It touched upon a few papers. So I'll share exactly on what these papers are. It touched upon ZFNet. It touched upon Resnet. It touched upon DenseNet, and mostly it gave me the platform that I needed to then go on my own journey and see where I want to go. Like, do I want to read the papers after this point where I started, or do I want to read the papers before I started? And then how is that going to look like for me? So I was trying to find my way amongst these thousands of papers that were there at the moment. And it was daunting at first. It was really hard to figure out what to do, because I just knew 2-3 papers at the time. I knew Fast AI library and I could train state-of-the-art results, but then I was like, where do I go from here? How do I learn? And how do I know? How do I get a grip on computer vision? So something I was doing, as I said, something I was doing, and this is a journey again, when I was learning about ZFNet, so I'll share exactly what these papers are as well. So this is, when I was learning about ZFNet, or when I was learning about Resnet and DenseNet, something I was doing on the side is that I was blogging about it. So when I learned something about DenseNet, I wrote a blog about it. So this is back in, even though this blog post is back in 2020, that's when the early 2020s is when I seriously started reading research papers every week. But as I was learning more and more about computer vision, I was constantly writing about them. So let me take you on a journey on how the first part of what's new in computer vision and how computer vision looks like. So the journey sort of started with neural networks in 2012. This is when Geoffrey Hinton and Alex, he was a researcher at the time as well. They wrote AlexNet. This was the first paper to ever be published. So at this time, from 2012 all the way to 2017, there's something called an Imagenet competition. So this went on until this point. And what this Imagenet competition is basically, it's there's different versions of Imagenet, but it's essentially 1.4 million images. Images of what? These are 1.4 million images of pets. These are 1.4 million images of pianos, football, basically every common thing that you can find, fish, or even humans. These are pretty much every common thing that you could find in the real world. What was happened is researchers got together and they created this huge data set of images, because then at this stage, what we wanted to do was people wanted to actually be able to train image classifiers. So 2012, AlexNet happened. And what AlexNet did, so the AlexNet architecture sort of looked like this. I won't go deep into, like, as part of this talk, I won't go deep into exactly what the architecture is, but I will give you a sense of how things have improved from 2012. So the key points to note is that when AlexNet happened and when this sort of journey started, the accuracy or the error rate was 37.5%. That just means that we were at about 63.5. Is that correct? No, that should be 62.5. So we were at 62.5% top one accuracy. What that means is the model that was trained in 2012 got 40 out of 100 images wrong when it was trying to classify them. And the next thing you will see, and you will see how this thing drastically changes, like this is where we started and where we end up is going to be completely different. And the next thing that happened was this first architecture was sort of trained on 2 GPUs. So what's a GPU? You must have heard of CPUs, but if you're in deep learning, you would have also heard of GPUs. A GPU is nothing but a graphical processor unit. And it's much faster to do some operations, especially the ones that you need for deep learning. It's really fast to do those operations on GPUs. But the key thing to note here is then, when AlexNet happened in 2012, you needed 1 architecture and 2 GPUs, and the accuracy was really bad. So this is where things sort of started, but it was a good moment. The reason why it was a good moment was because it brought neural nets on the map. This is where people started to feel, okay, neural nets or convolutional neural networks, it was the start of deep learning. It was the start of computer vision as we know today. So then 2012, 2013, 2014, 2015, and about 2016. 2017. So this is where the Imagenet competition went on. And what people were doing at this point, every year, what was the goal was to beat this, beat the previous year's benchmark. So if this one was at around 40% error rate, then the next architecture that came in said, okay, we're going to break this error rate. And then the paper that came around in this 2013 was the Zeiler and Ferguson paper. And what they did was, generally, as you saw in AlexNet, it's not, a deep learning network is not like a single layer. It's generally multiple layers. That's layer 1, layer 2, 3, 4, and so on. And what they did was they sort of visualized how a convolutional neural network actually learns about computer vision. So this was the first deep insight people started to get into computer vision. They started to see that the earlier layers only sort of, think of this as how we comprehend images, or how a deep learning neural network that's sort of deep, 5 layers deep, how this deep neural network sort of looks at images and how it understands images. So the really early layers sort of only get edges, or they get diagonal edges, or they get some very small patterns. These are like just images or just straight lines, but these are just the very basic patterns that the very early layers get. Then the next layer builds on top, and you get more patterns. So you start to see a top left corner. You start to see sort of a circle. And then the next layer builds on top of this, and you start to see those patterns being recognized. So if you have a pattern like this, you can see that that top left corner can now start to recognize windows or doors, or that's the idea. So the neural network or the architecture starts to build one by one. The early layers get the really basic things, and the later layers, and the deeper you go, the later layers actually do the classification. So as you go through your network from early layers to later layers, the convolutional neural network is starting to learn more complex patterns. So based on this, they designed another network, which was called the ZFnet. And that sort of broke previous year's record. And after that came VGGNet and InceptionNet. So in the 2014 competition, InceptionNet won and VGGNet was the runner-up. And what's the difference between the two? There's not much difference between the two. All they did was, at this point, it was starting to be realized that the deeper, or the, as I said, a convolutional neural network has layers, right? So The AlexNet had around 5 layers. But by the time it was 2014, it was starting to be realized that what we want to do is we want to have our convolutional neural networks actually be deeper. So the VGG net was around 16 to 19 layers, and the inception net was around 22 layers. There's nothing new, or there's nothing that was sort of, there's not a lot of innovation apart from making these architectures go deeper. So this is a VGG net. The major breakthrough moment came when the Resnet was released. So in 2015, Kai-Ming He, he's a researcher. They basically designed the Resnet architecture, and I'll show you something about the Resnet architecture. So as I said, by this time, when you're going from 2012 towards 2014, it was being realized that what we want to do is we want to have deeper networks. So instead of having 5 layers, if you have a deeper network of 16 to 19 or 22 layers, it was the assumption that the deeper the network, the better it's going to do. And the reason for that was deeper networks have more capacity to learn. And when you're trying to classify 1.4 million images into 1,000 classes, which is the Imagenet dataset, these deeper networks are going to perform better than the shallower networks because they have more capacity to learn, so they're going to learn better. And when the Resnet happened, the Resnet trained an architecture with 152 layers deep. This was 8 times deeper than the VGG nets. And the error percentage got down to 3.5% error on the Imagenet test set. So see how we've gone from 40%, although take that with a grain of salt. I'm not exactly sure what the test set here was. So it's not a direct comparison, but the key thing is then we went from about 5 layers deep to a network that could be 152 layers deep. And Resnet is what outperformed every other network that was there before. And when something like this happens, when the Resnet came around, they sort of introduced skip connections. That was what the main contribution of Resnet was. So I won't go deep into what skip connections are. There's plenty of blogs being written, but this is pretty much what a skip connection looks like. So to give you an intuition, then what happened with Resnet was due to that skip connection, it was really possible to train these really deep neural networks that had less complexity than all the networks that were there before. And when something like that happens, when something in history, when a paper like that comes around, you start to realize that if you start to tweak that paper a little bit, then you can still get good results. But every paper from there on until 2017 or until the Efficientnet paper, which was a bit different, the exception net, the ResNext, the SENet, sorry, the exception net, ResNext, and SENet were basically some changes to the ResNet paper. So the SENet is called the squeeze and excitation net. And when I was here and I was trying to learn about this history of computer vision, something I was doing on the side was, as I was learning about DenseNet, which came around here in 2016, so you can see DenseNet is here and SENet is over here, squeeze and excitation. ResNet is here. And as I was learning about all these architectures, and I was sort of getting my mind to get the intuition, okay, what caused this year to be different than last year in the Imagenet competition? I was also constantly blogging. So on my personal blog then, I added squeeze and excitation networks. So now we have squeeze and excitation networks that sort of explains, this blog explains everything that there is to know, the main idea behind SENets, and it sort of explains everything that this paper, the main contributions of this paper were. And just to keep the history of computer vision going, around this time, another paper came around, which was PNASNet. There's not much to know apart from the NAS stands for Neural Architecture Search. So around this time, then, the researchers got this idea that instead of manually defining or instead of manually sort of architecting these new models, how about we let deep learning decide on what the best model is? So we let deep learning learn the model architectures instead of us as researchers looking at what a new model architecture should be. So until this, all the previous architectures, if you have a look at BGGNet, which looks like this, you look at Resnet that introduced this skip connection, the DenseNet that looks like this, the ResNext architecture that looks like this. Until this time, then all these architectures were manually designed. But at this point in the PNASNet, what changed was that we let deep learning sort of decide. So we let an algorithm, which is called progressive neural architecture search. We let this algorithm decide on what the architecture of the model should look like. And this was a good change. And this was different than what had been done before. But until from 2015 all the way till around the 2019s is when the Efficientnet came around July 2019. Until this point, there wasn't much change to Resnet. So see, for 4 years, there was slight tweaks to the Resnet architecture, but there wasn't a massive change that was like, oh, this is another breakthrough moment. But that breakthrough moment, according to me, came when the Efficientnets came around. And why do I call this a breakthrough moment? The Efficientnets have been one of the best performing architectures in deep learning. When I say one of the best performing architectures in deep learning, I just mean they are efficient in the sense that you don't need a lot of computation to train these architectures. They perform really well. The Efficientnets broke every record in terms of accuracy. They performed really well on the Imagenet. They had really good accuracies, and these were really performant models that could be then utilized on mobiles, or that could be utilized on and they were like different sizes. So you choose your pick, but the smallest size performed better than the biggest sort of Resnet 152, which was 152 layers. So let me show you why the Efficientnet is different. So have a look at this. The Efficientnet B0, which was the smallest model, is performing better than the Resnet 50, which has 50 layers. And you can see in terms of the number of parameters, what number of parameters basically mean is just how big the model is. So if the smaller models had really good accuracies, like this is one of the smallest models with about 6.8 million parameters, and that was still able to get 77% accuracy. But for the around 70 million parameters, or one of the biggest models, there was no other model that at 70 million parameters was able to get 85% accuracy, around 85% mark. So that's why the Efficientnet was another big moment in the history of computer vision. And as I said, when something like this happens, when Resnet came around, which was a big moment, when Resnet came around, and all these other papers like ExceptionNet, ResNext, SENet, DenseNet, there were small tweaks to Resnet. When something like this happened in Efficientnets, there's all these other papers that came around. So you have Efficientnet Edge TPU, you have Efficientnet Noisy Student, you have Efficientnet Adverprop, you have Big Transfer Learning. And all of this was caused because we had something, the Efficientnet word released, and this caused a big sort of, this caused a big uproar in the computer vision world, and people were really like, oh, Efficientnet really works. And something you'll know is, you should know, is that Efficientnet used neural architecture search. So this is again using the same thing. That's neural architecture search. And as I was learning, as I was going on my journey, and as I was learning about these networks, then the next thing I did was I wrote about Efficientnets, because I realized that's how big a thing they are. So Efficientnets are here. And in this one, I teamed up with so Efficientnet. So this is one of the blogs that sort of was really popular, and it explains Efficientnets in a way that hasn't been explained before. This blog provides all the history on what neural architecture search is and why it's being used, and that's what is different, I feel, in the blocks that are right, is that what you want to do is you want to provide context. So as I'm going on this journey, and these are the various checkpoints in my life. So for example, DenseNet was a checkpoint, SENet was a checkpoint, EfficientNet was another checkpoint. And to continue the history, then when there were these other papers like EfficientNet, Edge TPU, Noisy Student, AdverProp, Big Transfer Learning, especially these ones, the Noisy Student, AdverProp, and Big Transfer, what they did was they were just bigger networks. So as I've said, bigger networks have better capacity to learn. Then what the researchers did, they said, okay, EfficientNet has the biggest one has about 80 million parameters. What if we can increase the architecture size, or what if we can increase the data set size? So instead of training on 1.4 million images that are there in the Imagenet dataset, the big transfer learning or AdverProp were training on GFT, which is Instagram images, which is around 300 million images. So you can see how the scale is now 300 times for the data set. And all of this was being caused because there was an improvement in GPUs, the architectures, the hardware was better. So this gave people the capacity, or researchers the capacity, to train these really, really big models. Now we're coming closer to today, which is somewhere here. So what's new in computer vision today? Apart from this history, I've got this small dot here in around 2020 in March, which was the Resnet paper. The Resnet paper pretty much combined the Resnet. Sorry, it combined the Resnext. Even try and draw it like this. It combined the Resnext. I'm really bad at this. I've just realized that I need to get better at using this tool. So it combined the Resnext, which is from here, and it combined the SENet. So that's what the Resnet paper was. It sort of took the best of both worlds of these two architectures from before, and Resnet was born. But something that's really new in computer vision these days, and to get context and to learn why that's new or what's happened, while all of this was happening in the computer vision world, if I have a similar timeline and I make a similar timeline for NLP, oh, that's too bold. If I draw a similar timeline for NLP, then around the 2017, which is somewhere here, what happened was the transformer architecture was born. So before this, typically in natural language processing, computer vision belongs to images. Before this, typically, you had RNNs or you had LSTM. But ever since the transformer architecture came around, transformer architecture has dominated the NLP field. So it was getting, like the Resnet moment, like Resnet happened, it was even dubbed the Resnet moment, the Imagenet moment, or the aha moment in NLP. When something like this happens, the transformer was such a big, influential, impactful paper that even today, pretty much all the architectures that are coming out in the NLP have their base from this transformer. So you had BERT, you had, if you've heard of these, you had BERT, you had GPT. Even today now, towards later, you have GPT-3. So those are the models that are coming in. But something that was happening then in NLP was this transformer architecture was dominating the NLP field. And the authors of Vision Transformer, they thought, oh, okay, well, it's great to see that Transformer is doing really well in NLP. What if we take this architecture from here and we apply this to images? This was another big moment. When I say big moment, it's the first time, like this had been tried before, but the vision transformer was the first paper that showed a correct way or a methodology or the algorithm. This was the one paper that showed this is how you have to train a transformer model. If you want to take the exact model from NLP, if you want to take the inspiration and you want to bring it to computer vision, then this is how you do it. So they showed the way, they led the path, and they showed the way for the next researchers that if you want to use the transformer in computer vision, this is how you do it. So this was the big moment in computer vision when the bit or the vision transformer was born. And this happened around mid-October 2020, around that time, so November 2020. And then when big things like this happen, what happens is other papers get born. So you have a diet, you have a Levitt, you have a Kate, a Convid, or botnet. So what these papers then, they're just tweaks to the vision transformer. So as you saw with the EfficientNet, when EfficientNet was born, there's all these other papers being born, not the ResNest. There's all these other papers being born, like Big Transfer, AdverProp, EfficientNet, Noisy Student. A similar trend has been seen in vision transformer. As part of my journey then, when I was learning, as I was going, I first learned about convolutional neural networks, and then I was spending time in NLP. So I was actually doing, Rachel Thomas has a course on NLP. It's a Fast AI course as well. So it's a Fast AI NLP course. And I was doing that to learn NLP while doing the convolutional neural networks, or while learning about DenseNet or all these other architectures. So this was a very parallel process. When I was learning about these architectures like DenseNet, as I've showed you, the DenseNet is there. As I was learning about squeeze and excitation, as I was learning about EfficientNet, this is again August 2020. As I was learning about these things and I was writing about them, I was also doing the FastAI NLP course on the side, which introduced me to the transformer. And when I learned what the transformer architecture was, that created a platform for me to then learn about the vision transformer. And when I learned about the vision transformer, you know what I did. I went and I wrote about it. So this is it. January 18, 2021. So see how it took me, I would say, in this few months, I was still doing other things on the side. Like I was learning object detection. I was participating in Kaggle. I got my first silver medal. But from that point to this point, when I learned about the vision transformer, I created this blog post. I teamed up with Dr. Habib Bukhari. He's ranked he's a Kaggle 2x master. He's a Kaggle competitions master, which means that he's one of the topmost people in the Kaggle world. And he's actually ranked 211 out of the 162,000 participants that are ranked on Kaggle. So he and I, we sort of teamed up and we wrote about the vision transformer. But I'll share the journey on the writing. I'll share the journey on the blogging in the next section of the talk. But this is how that sort of journey of learning about architectures and also writing about architectures look like. And then when the vision transformer was happening, and I'm learning about these other architectures now to date, it's much easier now to learn about all these other architectures because there's smaller tweaks. So that's happening in the vision transformer world. So now that's one line of research. So the one line of research that's there in computer vision is this one, which is using the transformer architecture. So this is just trying to use the transformer architecture from NLP in computer vision. But as you see, we've lost the convolutional neural networks behind because this is transformers. Transformer is very different from convolutional neural networks. So all this that we saw before, ResNet, ResNext, DenseNet, they're all convolutional neural networks. So this is a CNN, this is a CNN. Pretty much all of them are a CNN. And when all of this was happening, when some part of the researchers or the research world is using transformers in computer vision, there's another part that's then coming up with papers like this, NF-ResNet and NFNet. What's different? What this is trying to do is it's trying to take away batch normalization. So that's another trend that's happening. There's more follow-up papers on NF-ResNet and NFNet. These are also big moments in computer vision in the world today. This is, again, another trend that's coming up. And when I was learning about the NF Resnet, what did I do? I wrote about it. So here it is. I wrote about NF Resnets. Similar thing for NFNets. So as you go, I guess the thing I'm trying to say is everything that's happened to me didn't happen in a day, but it was not like I learned things in a day and then I've started writing about them in a day. It was all a journey. Like everything was happening with time. And as I was learning, I was writing about things. So this is the second line of research. Batch norm is a key component in all the convolutional neural networks before. This is, again, inspired by a CNN. At the heart of it is a convolutional neural network, but then it's not using any batch norm. And while the research is now coming up with new architectures, so this is the first one. The research today in computer vision is coming up with transformer, or it's coming up with the second type of architecture that's taking away batch norm. There's another line of research that is then coming up with the mixers. So the third line is don't use a CNN, don't use a transformer. Although it's how it is branded, I have my doubts about the MLP mixer in itself, the way it is the way it's architectured is still a 1D CNN. We'll talk more about this as part of the paper reading groups that I do at Weights and Biases, which I will share what they are. But the key idea then for an MLP mixer paper, these are researchers at Google that started with the MLP mixer, and then that's the third line of research that's coming out is don't use a CNN, don't use a transformer, rather just use a multi-layer perceptron that's just linear layers, and you would get something that will still work. Then that's the third line of architectures that's there today. So that's the main sort of, if you want to keep up with computer vision today, these are the three main trends that are happening. And everything that I've learned, I've sort of contributed, I've written about, but now it's much easier in 2021 for me to learn about these papers because I don't need context. I already have the context. So if there's, say, afterwards, if there's a new paper that comes around and I don't know what it's called, let's say it's called X, and X depends on all the other papers, A, B, C, then I've already read about these A, B, C papers. So it's much easier. So the journey is becoming easier with time. But that in a way is what's new in computer vision. This is the timeline that looks like for computer vision. And if you want to sort of take from what I've shared today and you want to take it back to your business, these are all these different research trends or architectures. I would definitely recommend trying NF Resnet on your deep learning models. I would definitely recommend trying the vision transformer, and I would also recommend still using the efficient net. So in fact, something that's just recently come out, I don't have this, I should. Something that's also recently come out is the efficient net V2. That's just the second version of efficient net. It's a better version of efficient net, and that's come out. So I would definitely say if you want to take this back to your business, try these three architectures: efficient net V2, vision transformer, and the NF Resnet or the NF net. And there's like different data augmentations, different training pipelines. Try all of them, and then ideally, if you want to have a state of the art, see if you can join them together. You can basically, you create an ensemble. So you take the predictions from these three different architectures and you ensemble them. And the best way to get started in code would be through this library called PyTorch image models. This library has every architecture that I've mentioned so far. This library has got it in itself. So, and it's so easy to use. All you need is you import this library and you create these models just through one single line of code. But that's it for this part of the talk. If there's any questions, I'll take them. So let's take 2 minutes for the short questions about what's new in CV. And then from this point onwards, I'll go. I've already given you a gist of how I publicly share my work is as I go, I learn about things and I write about them. But let's take questions on the CV side of things and computer vision architectures.
Sure. So Aman, the first question from Yurajesh. Neural architecture search means architecture is defined by the model itself. Can you please put more light on this?
Sure. I would recommend you to my previous blog on efficient nets. In efficient nets, if you go to this point where it says efficient net architecture using NAS, which is the efficient net architecture using neural architecture search, this will explain everything that you have a controller, you have a trainer, and this is how the deep learning is coming up with new architectures on their own. But yeah, definitely have a read through this, and this will explain neural architecture search in much detail. Let me share this in the chat.
And Aman, neural architecture search, at least I know last time I had a closer look at it, tends to basically build the layers by having a predefined set of possible blocks and basically plays Lego and tries a bunch of different combinations and sizes, right? I'm curious, particularly in the last year or two, has that sort of predefined list of blocks, has that expanded, or is the model now more able to modify or create its own types of blocks? Like, what does the future look like? Because it seems like there's going to be more and more models, of state-of-the-art models built using this technique.
Yeah, great question. So I would point you to the EfficientNet V2 paper that's just come out 1st April and then last revised 23rd June. But to answer the question, Michael, that's a great question of if the blocks have increased. It's basically playing Lego. So to provide context to those that, just some bit of context, just look at this. It's like you have 3 sets of pairs, or let's just say you have 3 sets of things that you can use. You can use different convolution sizes. You can use different, say, non-linearities. I'm just going to call it NL, or you can use different model blocks. So I'm just going to call it M block. And then what you do is you try different combinations of these, and you come up with an architecture that's sort of a mix of these different things. So the question Michael's asking is, has this changed? Has this block of Lego blocks that this neural architecture search then comes up with, has that changed in recently? And the answer is 100% yes. So EfficientNet V2, and this is something that we just discussed on Wednesday. So at Weights and Biases, we also host paper reading groups where we look into all of these recent papers. As you can see, this is where it says, the models were searched from the search space enriched with new ops such as fused NBConv. So the answer is yes. And that search space, or that sort of Lego pieces, are changing and being updated even today. Hope that helps.
Sure, cool. Awesome. Thanks, Aman.
All right, is that all questions then? Should we move on?
Actually, I might have a couple more. Thinking about transformers. So transformers are a lot larger, but more importantly, they're slower to train because of their architecture, obviously. I'm curious, early on, I think it was back with the AlexNet model, it was 2 GPUs to train it. Obviously, it takes, a lot more GPUs to train even the latest CNN models. With some of these transformer models, what sort of size are the training clusters to train these from scratch, in order to get the sort of pre-trained models that we've got, or you might be able to use through the PyTorch image models library? And what does that mean for, taking a pre-trained model and fine-tuning it? Is it as quick as, fine-tuning a 152-layer ResNet, or what's the sort of difference in time required?
Totally. That's a really, really good question. So something that I should mention as well, a difference between transformer and CNN. So I'll say CNN over here, and I'll say transformer over here. One of the key difference between the two has been the data set size on the pre-training. So the data requirement for a CNN is typically 1.4 million images, like that's what a CNN has been trained on, which is the Imagenet. Whereas the transformer requires around, like it had to be trained, when I said the vision transformer was the first architecture that took the transformer from NLP and applied it to computer vision. It was using the GFT dataset or the Imagenet 21K, which are really big data set sizes compared to compared to a CNN. But in saying that, this is where it first started. Now the effort from transformers are moving from using dataset sizes of 300 million to dataset sizes of back to 1.4 million. So papers such as diet, they use knowledge distillation, or that's what they're trying to do. So they're trying to reduce that dataset size. So in terms of what the future looks like, there's a lot of architectures that have come out that are at the intersection of these two. So I'm just going to create a block like this here. And these architectures are Convit, that has come out, botnet, which is bottleneck. And what they're trying to do is, in the model architecture, in the earlier layers, you use a CNN, and in the later layers, you use a transformer or attention. So in terms of training, or in terms of what's happening in the future, is like people have realized, oh, transformers are really good as well, because they have a really high capacity. Like they're really big and they can learn a lot of things, but they're a bit slow, or they have really big computation requirements. So typically you need like a 128 TPU, and it's like 1,000 days, which is a lot of compute to do a pre-training. But even with CNNs, bigger sizes, it would be, say, a similar size, but it's still much better in terms of speed. So where the future is headed is these sort of networks like Convid or botnet that are using both of them, or even Diet that sort of uses knowledge distillation, but you still need 1.4 million images. So it's still it's an area of active research, but there's definitely transformers out there that can match the speed of convolutional neural networks in terms of pre-training.
Cool. There's a question there from Ken. Is there a concept of developing a sparser model which gives you a smaller footprint and compute for inferring from the model, or perhaps when training using transformers?
I'm really sorry, I don't get the question.
It's down there in...
Yeah, I'm just trying to understand the question.
Cool. Ken, maybe if you want to clarify what you mean. Quick question from me. These transformer models, you mentioned the PyTorch image models library. Are they also available in other libraries like Detectron or MM Detection or Fast AI?
Not at the moment, but team is the best way to go forward.
Okay.
Cool. Let's not take any more questions for now, because I'm curious of covering the blogging side of things as well, and it will take another 20 minutes at least, I assume, to get into the next part. So as I said, this has all been a journey, and I wanted to spend a major bulk of my time in this chart and explaining what's new in computer vision or what's upcoming. But then the next thing that really helped me in my career, or the next thing that sort of changed who I am, or it's sort of changed, it took my career from point A to point B, of course, point B being much better, has been to publicly share my work. And that thing has been it has been basically then, because I've been writing things about everything that I was learning, I was in the public eye, and being in the public eye really helped me. It created a good brand for myself, and I could use that brand. In the past 2 or 3 interviews, I've never had to share a resume. All we do is we pretty much discuss a blog that I've written, but that blog in itself is technically competent enough that can then share all the knowledge that I have, because it's all written down in a blog. So this is something I would really push everybody in this call to actually start doing, is that you want to start writing. So one of the recent, we hosted Parul Pandey. It was today. We hosted her today at a Weights and Biases event, which is the Fast Book Reading Group. So I know, Michael, at Queensland AI Hub, you're hosting the Fast AI course. At Weights and Biases, I'm also running a fast book reading group along with Sanyam, along with Zach, Tanishq, and Parul. So the community has come together, and we're also learning fast AI as part of that course at Weights and Biases. And Parul has this really good really good post on how to publicly share your work. So if I go to Weights and Biases forums, I just want to bring a link for this post, because it's really, really nice. It's called Building a Compelling Data Science Career Portfolio with Writing. So I'll share this with everybody in the chat. In this, you'll find all the basic things that you need, pretty much things you can write about. So this will give you ideas on if you want to get started, how you can write about things. And then the best part of this is it will give you all the resources to get started. So if you can get started with blogging, if you can create your own blog, Fast Pages is definitely the way to go. It's the easiest, but there's also all these other things that you need as you blog. So these are all the resources, and it will help you in your journeys. I have a blank slide because my journey was sort of different. And that blank slide is because I wanted to write things here. So I'll share things that have worked for me. So when I started on Twitter. So Twitter, for ML folks, as Jeremy has also mentioned in the past, Twitter is the place to be if you want to share your work. Twitter will give you sort of a loudspeaker that you can then share your work with a lot of people. So typically what you want to do is you have a public profile on Twitter. This is what I had as well. I started with, I think, 50 followers or something. And this is just a journey. It's not to say that I have 2,000 followers today or 2,500 followers today. In fact, I don't even know the number. But the key point is that that number of followers has increased. And what that means is that my distribution system has increased. And how that happened was being very consistent. So when I first started blogging in 2020, pretty much every week or every 2 weeks, I've had a new blog come out. So as I was learning things, I still spend every day of about 3 or 4 hours just learning something new. That could be reading a new paper, that could be looking at code. But I still spend a lot of my time learning about things, and I still spend a lot of my time writing about things, which is what you want to do. You want to be consistent, because if you're not consistent, then if you write a blog today and then you write a blog in 2021, that's also still okay. But what definitely worked for me was being consistent. I think people prefer having consistent people. And also then, if you continue to learn, as I mentioned in the journey over here, because I've spent now a lot of time, then everything new that is coming, it's easier for me to get the context. And that's through consistency. So that's the main point that has worked for me. But I have three key takeaways for everybody in this call, which I will share on the things that have worked for me. So the first thing has been to have a growth mindset. What does that mean? I always ask myself, are there ways I can improve? Is this the best way to present an idea? Or can I do better? Can I provide enough context to the reader? So when I'm writing a blog, I'm actually trying to write the best version of the blog. And what that does is it pushes me to learn more. So if I want to write the best version of a blog for a research paper, if I'm writing a summary, then to write the best version, I need to have the best information. I need to have the best knowledge, which means that if I'm trying to write a research paper on Resnet RS or any research paper today, I will actually spend 2 hours or 20 days, depending on what the paper is. I would spend that much time on just getting context, on just understanding the paper, and getting enough context for that paper. So that's the growth mindset. And what that has done is that it's worked very well for me. So when I was starting with, recently I wrote about revisiting ResNets, which is another paper that has just come out recently. I try and convert these things as I'm learning through things, I'm writing about things. And then what that has done for me is that it has created opportunities. So when I was writing about revisiting ResNets, Barrett Zoff, he is the author of Resnet RS. He works at Google Research. He retweeted my tweet and he said that's a great blog post on a recent Resnet RS work. Now that's really high impact because it's good for me and it's good for the people that shared. Because if the researcher himself who's written the paper is resharing your work, then in a way that makes me believe the context that I've provided or what I've written can be considered a source of truth. And the next thing that happened just from writing this one blog, because I wanted to write the best version of it, we had Arvind Srinivas. He's also a co-author of the Resnet RS paper. He and I sort of connected, and we kind of every 2 weeks, we host a paper reading group at Weights and Biases. So as you can see, we're excited to announce that I'll be joined by Arvind Srinivas. And this is the date that we had our computer vision paper series. And then what that happened is just through this blog, because it had enough traction that I could reach out to Arvind Srinivas, and we started talking. And then I could invite him to be a host at Paper Reading Group. And then that meant I could ask the questions I wanted to ask directly to the research paper author. And as part of then, because I say it takes me either 2 hours or 20 days, depending on the paper. As I was working on the Resnet RS paper, then something else I was doing was I have a code first sort of mentality. I don't think a paper is considered complete unless I know how to write it in code. But at the time when I was learning the Resnet RS paper, this only existed in TensorFlow, and porting weights from TensorFlow to PyTorch can be considered real pain. But I took it upon me. It took me, I think, 3 or 4 weeks through on and off work. And I then added the Resnet RS models to PyTorch image model. So that's the library that I've shown you. So if I go Resnet RS, there it is. The model weights have been come from TensorFlow. And the PR for this was actually about 100 comments or something, because it was a really stressful process. It was really hard for me to do this or to understand ResNets and then move them from TensorFlow to PyTorch. But as part of this process, I learned a lot of things. And then the last thing then that I try and do is, as part of all the blog posts, I try and provide all the context. So a Resnet RS paper, when I say, when I said, usually papers like that come out like X depend on past papers like A, B, and C. Then what I try and do in all of my blog posts is I try and make it to be a central place for somebody new that's coming. So if you're somebody new and you want to learn about Resnet RS, and then Resnet RS depends on all these other things like model EMA, label smoothing, stochastic depth, brand augment. So if you go to that blog, that will provide context for all of these things. So if you go down, you'll see what an EMA is. As part of this, you'll see the code for EMA, label smoothing, stochastic depth, all the context. I try and provide all the context with code in all of the blogs that I write. So that's the first thing. That's the first mindset is this the best version, or is this the best version of the blog that I can write? A very similar process then happened with Convit. So very recently, we were hosting, I was trying to learn about the Convit paper that, as I've mentioned in the timeline, is somewhere here. This is the Convit paper. I was trying to learn about the Convit paper, and then I was trying to write about it. There were some questions that I had, but as part of this, again, took the Convit paper, added that to PyTorch image models library, because then I learned how it is implemented in code. But what happened is then I was able to get on a call with Stefane. He's the author of Convit from Facebook AI Research. And he got on a call with me and he answered my questions. And then what I did was, with that perfect understanding of the paper, then I wrote this blog post. And what that ended up into is then Stefane was again a part of the Convit paper reading group at Weights and Biases. So it's like a journey. It's like small dots connect. But this is the first mindset that I try to keep. The second mindset that I try is always be helpful, give back to the community. So and this mindset is what brings me to this talk here today, because I don't want to keep everything that has helped me as a secret. I want to keep that as an open book, and I want to share it with everybody that's in the call today. And that's the Fast AI mindset. I learned this from Fast AI. I learned this idea from Jeremy Howard. So Jeremy Howard, he's built this library, Fast AI. He didn't do it for himself. I think it was more so to give back to people who can then come and learn deep learning from all these different parts of the world and all these different professions, and they could then pick up deep learning. And I personally am one of those people who came from a quality analyst background and then picked up deep learning. But that's the Fast AI mindset. That's what, because I learned from Jeremy, who was being very selfless, and he was the one who was who sort of created this community. I thought, is there a way that I can give back to Fast AI? Is there a way that I can give back to Tim? So Tim is the PyTorch image models library. And what that has turned into, it has turned into projects like Fast Download. So Fast Download is, again, a very recent project that's on Fast AI. And I got the opportunity to work with Jeremy on this library. So Let me show you fast download. So then fast download is then a part of the Fast AI organization. But being able to give back, having this mindset of being able to give back to Fast AI has led to a project such as this one, which has been tremendously, which I've benefited from in terms of like how to code, or I've got to work with a mind with a much bigger and a much a person who knows, who has 3 decades or 30 years of coding experience. I think it's 4. I can't remember if it's 40 years or 30. But then this gave me the opportunity to work alongside Jeremy and just ask him questions straight away. Another thing then that happened is the PyTorch image models turned out into a Team Docs project. So Team Docs again is hosted at FastAI, but what this is it was mostly to realize that the PyTorch image models is lacking some of the documentation. So then I went in and I helped with the documentation. So it doesn't always have to be code, but I went in and I sort of provided context for everything that this library can do. So it's a lot more than just the model hub. But this was the second thing. And then that got me recognition. So on the README of the PyTorch image models, if I go to PyTorch image models, if I search for Team Docs, then in the getting started documentation, there's definitely Team Docs being mentioned. So which is, again, I've tried to give back, but actually I've gained more from giving back, if that makes sense. And then this mindset of giving back has then led to Jeremy Howard coming to Weights and Biases, and he was there for the fast book reading session. So I thought, because I've benefited so much from Fast AI, is there a way that I can help a lot of other people around me? And is there a way that we can then teach Fast AI to other people? So I thought of starting the fast book reading group, and Jeremy turned out to be, he's very kind, and he said yes, and he said he'll attend for the introductory session and he'll help. And I think it's very similar to how he was here at Queensland AI Hub to kick off the Fast AI course. And then what that has turned out into is this really massive this is just the top 5 or 6 tweets that I could find, but it's turned out to be into this really massive course that now people have started blogging. So Ravi Mashru, he started writing his own blog. Parul was one of the guest speakers, as I mentioned today. Vinayak has then built this app that can classify, I believe he's built this app that can classify cartoon characters. I can't remember, it doesn't mention in this tweet, but Korean, he started his own log of learnings. He started his own blog. Tanishq Abraham, he's 18 years old and he's a PhD. Another wonderful person, but he was there as a guest lecture. As a guest speaker, sorry. And then people really saying nice things about Fastbook, like I wake up early Thursday only for this. So that's been very rewarding experience so far. But it's also really rewarding to see that people are actually learning and benefiting from these efforts. And then the last mindset has been the code first mindset. So as I said, just casually in my talk previously, was that I don't consider a research paper to be complete unless I've implemented that in code. I truly believe by that, because I feel like a lot of the detail is in code. So it's easier to read the paper and get a general context, but it's much harder to be able to actually understand how you can implement everything that's been mentioned in the paper in code. And in that sense, the PyTorch image models library has been really helpful. So what I've tried to do is every time I read a research paper, I take up the code or try to implement it myself. And as I said, when I started my journey of blogging on my personal blogging, I was the first person then to come up with the annotated GPT-2. So the GPT-2 was a really popular, really popular NLP transformer model. So this is somewhere on the timeline over here when I said I was learning NLP. And then the GPT-2 was another really popular model. And what I did was then I converted that into everything, the annotated version of it, which meant every part of the research paper or every paragraph is then converted into code. So I sort of build that whole code or this blog post that showed people how you could implement GPT-2 in code, and which was a really big career-changing thing for me, because then that led to 160,000 impressions on Twitter and over 10,000 engagements, which meant I made my name in the public eye that I can write these blogs, that I'm capable of writing these blogs. So I never have spoken publicly about these things before, but these are the things that have been really rewarding, or these are the things that have been sort of sort of checkpoints in my life that have changed my life from point A to point B. And then same thing for having like a code first mindset is not just looking at research papers, but also looking at interesting libraries. So I was working on the Hugging Face Accelerate library, and in few lines of code, then you can train your PyTorch models on multiple GPUs. You can train your PyTorch models on TPUs. And then I thought, okay, how does that happen? Like, how is this even possible that with 2 or 3 lines of code, you can actually convert a Hugging Face Accelerate can let you do all of this stuff that has been so difficult to do in the past, that to do it in pure PyTorch is absolutely painful. And then how is this library then work? So I spent time, I again spent about a week or 2 then just looking at the code of this library, which then was born, which then led to another blog post, which is Inside Hugging Faces Accelerate, which has been also really popular. So this sort of blog post then shows you how the Hugging Face library is built, how it is designed, and it's again a code first sort of mentality. So I didn't realize I have a description here, but this is exactly the question I asked myself. Could Accelerate really be this easy? And the result is this dive into the internal workings of the package. So it doesn't have to be research papers. It could be anything that interests you, and that could be converted into a blog. Similar thing for when I was starting with object detection at the time. A lot of research papers, or a lot of research paper summaries that existed in the wild were missing the efficient dead architecture in PyTorch. This wasn't there. There was some context on what an efficient dead architecture is, but none of the blog posts actually showed how to implement efficient dead architecture in PyTorch. So this has been my latest sort of thing as well. Now I'm working on an object detection library, but this is again a code first mindset. Is a research paper is not complete unless I've learned how to implement it. And Ross Whitman has been like, I follow his code religiously. His implementations are really, really good. PyTorch image models is definitely the library to go for. And he also has this efficient at PyTorch repository. So let me show that. So this is the efficient PyTorch library. What I did was then I went in and I sort of had a look at how efficient that is implemented, and that got converted into a blog post. Something I forgot to mention is as part of this exercise of looking into Hugging Face Accelerate, I got to know Sylvain Guger. He's the research scientist at Hugging Face, and through that connection now, what's coming at Weights and Biases next is another event where we'll start looking into ML frameworks, and Sylvain is going to be the first guest. So it's sort of like, do your work, but do it religiously enough that what you do, you really believe it's the best version of that work. And then finally, again, Adam and friends. So I'm just sharing these examples because this isn't something that happened in a day. But something I try and do is when I'm reading a research paper, I try to recreate that research paper. I try to recreate the exact same charts. So I sort of implemented then when I was looking in optimizers, I sort of looked at how optimizers are implemented internally in PyTorch. And then I created my own simpler version of these optimizers. So RMS prop then looks like this. That's the curve of RMS prop. So RMS prop is straight from PyTorch, but my version of the optimizer that's much simpler also matches the exact same curve. So I've been able to recreate the RMS prop, but in lot less code, and I've also been able to share everything that I've learned as part of that process in a blog post. A similar thing happened for NF-ResNet. So as I've said, I'm trying to, in a research paper, I would see this chart, but I would ask myself, okay, this chart is good enough. Can I recreate it? And then I try and I used Tim, and I sort of recreated that, and then that became a PR, or like a pull request that was the extra addition of my contribution when I was reading this paper to the PyTorch image models. So yeah, so that's just me sharing the work on Twitter, and that gave me recognition from Ross Whitman himself. He's the author of PyTorch image models, who I've learned a lot from, and he says thanks for the contributions. So that has all been a really, really good experience. Oh, sorry, I'm pressing left instead of right. But that's pretty much it in terms of the 3 main learnings. Have a growth mindset, have a code first mentality, and then it's basically then just believe that if the version that you're writing is that the best version? And be giving, be helpful, so give back to the community. But that's it for me. I'm happy to take questions.
Awesome. Thanks so much, Aman. I think the first question from Sanyam earlier on was, could you please speak about consistency in your journey? I know you created the awesome blog post regularly every 15 days. Why was that important to you?
When I started, I didn't think that I would write a blog post every 15 days. But something that happened is, as I was learning, what was important for me was to share that with others. So when I started, I started with no context. I started as a quality analyst, and everything that I learned was through a painful process of then digging into source code. And I felt that nobody else should go through that painful process. So what was important to me was to try and take that pain away by sharing the work with code. And because I was learning regularly, so something that just happened is I was writing regularly. So it wasn't like I have to write a blog post every 2 weeks, but it just happened to be so.
Cool. Not sure if you can see the next one from when. Did you do all of that in your free time or as part of your job?
That was all part of my free time until I joined Weights and Biases 3 months ago. But at Weights and Biases now, a lot of what I'm doing intersects with my job, which is to experiment with new things. And yeah, so until that, everything was a day job was a separate thing that I was doing. And then learning all of these things and trying to get better was on the side.
As you were obviously writing these technical blog posts, you had to do a lot of learning along the way. It's, I guess you were writing the blog posts to learn the concepts. But now that you're working at Weights and Biases, how much of your time is spent engineering? How much is spent doing the same sort of stuff that you've been doing? And I guess, how has all of that practice set you up for what you're doing now?
Yeah, that's a really good question. As I have mentioned in the past, that so I'm still continuing to learn, but what that happens is when I'm learning Resnet RS or write a blog post about Resnet RS, which is in my head the best blog post that I can possibly write. I'm not saying it's the best blog post that can ever be written, but in my head it's just the best blog post that I can write. Then what happens is, because you make connections with like Barrett Zoff, the author of the paper, retweeted, and then I made a connection with Arvind Srinivas. Then what that happens is all those connections get converted into events or my job responsibilities sort of thing at Weights and Biases. So that's definitely helping me. Like when I'm doing a convid and I'm doing a paper reading group at Weights and Biases, then because I've written convid, I can host a paper reading group about convid at Weights and Biases, and then I can then have Stefane as a public speaker at the paper reading group. So a lot of that intersects in the sense that, sorry, I've lost my screen, I believe. 1 second. Yeah, I've definitely lost my screen.
That's all right. We've still got you.
Yeah, okay, I can't see the screen anymore. 1 second, that's really bad. And I don't know how to fix this. Okay, I've got it back. Finally, just some keyboard. Anyway, so then now what happens is I'm still spending a majority of my time learning, but it intersects at what I do at Weights and Biases. So if I want to do experimentation at Weights and Biases, then because I've spent time learning about these architectures, then I have ideas to do experiments that then leads to better experiments. So it's like a loop. The more you learn, the better experiments you can do and the better you get at your job.
Out of curiosity, you've obviously worked with a number of people who do a lot of open source contributions. How many of them do all of this in their free time, and how many of them, after doing it for a period of time in the same way that you have, managed to land roles at companies where they essentially get paid to, build their projects and release them?
I would say from the ones I've met, all of them. And the reason why I say that is, if you're doing something outside of your job, then that's not what you want to do as part of your job. If you're spending that much time or effort outside of your job learning about deep learning, then that is what you want to do as part of your job as well. You don't want to spend 10 hours a day doing plumbing, whereas deep learning is what you want to do. Not to say that I was doing plumbing, but that's just then, so what I've seen is then, what that happens is I personally try and aim for excellence. The job or the benefits or all those sort of things happen as you learn things and as you keep going, as you keep becoming better and better. So that's what I've felt, and that's what I've seen as well, is like, at least for the people around me. And I would take the name of Sanyam. Sanyam is he's attending here today. I've seen Sanyam have that sort of same tenacity, and he's sort of done 2 podcasts a week, I believe, and he did that for 52 weeks, which was a lot of his time and effort. And then in turn, I know that has landed it into a really good job. So it's like, yeah, it's like it's again like a loop. So if the more you learn, the better jobs you get prospects for. And I've seen everybody who spend that much time into yeah, I've seen everybody who spend that much time get good roles and good jobs.
Awesome. I think we'll take one final question from Alice in the Q&A there. Alice's question is, how do you see machine learning, computer vision progressing in the next 5 years?
I don't know how it's going to progress in the next 5 days. It's just the reason I say that is deep learning is a field that I've seen has changed so much in the past, say, 1 month. There's like a new thing that's coming out that you can't really predict on what's going to happen in the next 5 days, let alone 5 years, because in the next 5 days, people who are doing deep learning, they're full of ideas, and we haven't hit the benchmark on what deep learning can do. Deep learning is going to change this world. It already has been. But then how or what that journey looks like is really hard to predict. But I do believe that for the next 6 months or a year, I do believe that transformers are definitely going to be in there. That's a really key innovation that has happened, is the vision transformer. And then I do believe that having the normalizer free networks is again a definitely key moment. But as you saw with deep learning, when something like Resnet happened, it only lasted 4 years. Or when Efficientnet happened, now there's other things that are coming up that are competing with Efficientnets and that are becoming better. So deep learning is a field that's becoming better and better every few months or every few years. It's really hard to say what's going to happen after 5 years.
Yeah, I think the sort of progression, particularly with neural architecture search, and obviously it's becoming harder and harder for single researchers who don't work at Google or Facebook to put this stuff into practice. It'll be interesting what the next few years look like as far as, you know, these bigger and bigger models and how we get there and how they're created, whether it's from a researcher or in an automated fashion. So awesome. Thanks so much for your time, Aman. It's been awesome hearing from you. You've clearly spent a lot of time reading a lot of papers, contributing to the community. It's really awesome. Great to have you involved as well in the Fast AI course. Yeah, thanks again. Everybody, thank you for sticking around and keeping an eye on Aman. Aman, where can everybody follow you or watch you or do whatever they would like to do?
Oh, sorry, that's a good one. I should have had that as part of, but I'll share my Twitter. I think that's the easiest way to go, because that's where I tweet regularly. I'll just post that as part of the chat when I can find it. Yeah, I found it. So just post in the chat. That's just my Twitter. Over there, I think you'll find links to blog posts. You'll find links to LinkedIn and everything that you need to know. But that's the central place.
Perfect. And Aman, we were talking earlier before the talk started about that paper reading group. When does that one run for anyone in Australia?
Yeah, good point. So the paper reading groups run every 2 weeks at Weights and Biases, and they're Wednesdays at 1 p.m. And what the idea is then to host such paper reading groups is, again, to give back and to sort of discuss what's new in the deep learning world. So I mentioned Efficientnet V2 today, but we just discussed it yesterday. And then the next paper that we're discussing is the MLP mixer. So it's trying to get the community together, and then everybody discusses these recent papers. But we do it every Wednesday, 1 p.m. every 2 weeks. So the next one's going to be 14th of July.
Awesome. And just to give a little bit more info, so I guess, you know, there's not a lot of researchers in Brisbane, right? So would you say that these reading groups are a great way to actually, you know, get to ask questions and meet some of the top researchers on some of these top papers?
Yeah, totally. I try to have the researcher, like I try my best to have the researcher who's written the paper be part of the paper reading group. It's always not possible. But for the next MLP mixer, the Dr. Habib, he's a specialist, and he's been in the industry for I think 5 or 10 years. And he's going to be there. But before we come with the paper reading group, we generally try and proofread everything that we're trying to present. So we share it with people that we know would have answers to the questions we have. So we come prepared to the paper reading groups. And then we generally, as part of the paper reading groups, also share these blogs. So Dr. Habib, it's not confirmed yet, but 90% he's going to be there for the next paper reading group as a guest. He's definitely the person I ask all my questions to. So if he's there, you should ask all these questions to him as well, and not to me. But yeah, they're definitely, to answer, they're definitely one of the best places to ask all these questions, and yeah, to basically learn about the recent research.
Perfect. That's awesome. Looking forward to that one. I know that a few of the team at work as well will be keen to join. It's a great time for Australians, which is unusual. So that's awesome. Thanks so much, Aman, for your time preparing this and obviously talking. Looking forward to seeing more of what you produce, the awesome blog posts. Thanks everyone for joining us for another Queensland AI meetup. We'll see some of you hopefully in the next week or two at the Fast AI course that we're running. For everyone else, we'll see you in about a month. Thanks again, and have a great week. Try to get some sun, everyone, and get some exercise, given we're in lockdown. Thanks, everybody. Have a good night.
Thanks for having me, guys. Have a good night.